All right, so in this lesson, we are going to extend our understanding of circumference and we're going to learn about what we call arc length. So before we actually talk about what arc length means, we're going to do a little discovery activity with this table. And so what we're going to do is we're going to pretend when we look at these partial pieces of circles, we're going to start by pretending we actually have the entire circle. So what we're going to do is we're going to calculate the circumference and we're going to leave our circumference in exact form. So we're going to leave pi in there. And then we're going to take a look at the fractional piece of what we were given. We're going to actually look at our figure and figure out what fraction of the circle we have, and then we'll get into what arc length actually is. So if you look at this first example, we have a semicircle, which we know a semicircle is half of a regular circle, but I'm going to pretend like I'm going to find the circumference of the entire circle. Like I actually see the whole circle there. And so when we think about circumference, we know circumference is 2 pi r. We also know circumference is also pi times diameter. Okay, so if I want to find the circumference of this entire circle, I personally prefer pi times diameter. I can see my radius is 6, which means my diameter has to be 12 centimeters. So if I substitute that into the circumference formula, my circumference is going to be 12 pi centimeters. And that would be for as if the entire circle was there. But when I look at this picture, I don't have the whole circle. I have half of the circle, right? I have a semicircle. Well, let's think about where that half came from. I mean, we can easily look at that picture and see that the semicircle is definitely half of a regular circle, but let's take a look at the angle measure. The angle measure we have, that central angle is 180 degrees, and if we think about how many degrees are in a circle, we can recognize that 180 degrees out of 360 is equal to 1/2. And so we can take the fractional, or we can take the central angle that we're given, put it over 360, and then simplify that, and that will also tell us the fractional piece of the circle that we have. So now, arc length is essentially, I'm going to use a different color here. Arc length is a fraction of the circumference. So when I look at this, since I don't have a whole circle, I have half a circle, my arc length, which we denote with this letter S, my arc length in this case is not going to be 12 pi, because 12 pi is the whole circle. My arc length, or this piece in red, is going to be half of the circumference. So remember, arc length is just a fractional piece of the circumference. So since I have half a circle, I'm going to take that times the circumference of the entire circle, and that tells me that that piece in red, that arc length, so this is the arc length, is got to be equal to 6 pi centimeters. So let's take a look at the second one. The second one, when I look at this, I can see that I have a quarter of the circle, okay? So if I were to pretend like the whole circle is there, okay, if my radius is 5, then that means my diameter would actually be 10 centimeters. So the circumference of the entire circle, if the whole circle was there, would be 10 pi centimeters. But I don't have the whole circle. I only have a fourth of the circle. And when I think about how does 90 degrees relate to 360, we can see that if I were to simplify 90 over 360, that simplifies to 1/4. So if I want to find the arc length of just this quarter piece, if I just want to find this distance here that I've highlighted in red, I need to take my whole circumference, which is 10 pi, but I need to take a fourth of it, since the piece that I have is 1/4 of an entire circle. And so when I do that, I get, if I do 1/4 times 10, remember we want to leave our answers exactly, so that means when I have a fraction, or when I'm going to multiply these two and I don't get a nice pretty whole number, I need to leave those numbers in a simplified fraction form. So 1/4 times 10 pi would leave me 10 pi over 4, which that would simplify to 5 pi over 2. And so the arc length of this piece here of a 90-degree central angle is 5 pi over 2. So let's take a look at the last one. The last one we have, if we want to find the circumference, we see that our radius is 7, which means our diameter would have to be 14 centimeters. So my circumference is 14 pi centimeters. And this one might be a little harder for us to figure out, like, what fraction of the circle is actually represented here. So that's where we can just rely on our central angle and knowing that circles are out of 360 degrees. So if I set up this fraction here and I simplify it, I get that this simplifies to 1/6. So if I want to find the arc length of this piece right here, okay, remember it's a fraction of the circumference, my arc length is going to be equal to me taking 1/6 of the entire circumference, so 14 pi. And so my arc length is equal to 14 pi over 6, which simplifies to, let's see, these are both divisible by 2, so 7 pi over 3 centimeters. So if this little table made sense to you on how we find the arc length, like how do we find the fractional piece of the circumference of a circle, then you essentially have figured out how to calculate arc length. You've kind of discovered the formula. And so if we look down here, okay, so remember, arc length is just a fraction of the circle circumference, and we measure it in linear units, so it's not squared units, okay? And so if you look at this green piece here, okay, finding arc length is essentially finding the length of that. So if you were to straighten out that curved piece into a straight line and measure it, that would be how we find arc length. However, since we have pictures of circles on our pages, we can't exactly like take the arc and flatten it and then use a ruler to measure. And so that's where we have to use a formula. Well, we just discovered that formula. And so essentially, if you think about, well, how would you describe to someone how to find arc length? It's just a fraction of the circle times the circumference of the entire circle. Another way to think about it too is that we were essentially looking at our central angles. So we were taking our central angles out of 360 degrees, because that's how many degrees are in a circle total, times the circumference. So we think about circumference, we were using pi d or 2 pi r. So like you could kind of decide which of these you prefer. Now the true arc length formula tends to use 2 pi r, but if y'all prefer pi times diameter, you can certainly use that when you go to calculate arc length. And so since we kind of discovered the arc length formula, if you look here, you can kind of see what we discovered is exactly one of the formulas. Like this is kind of the most common formula, and you can see we took the central angle, so this theta symbol really means central angle, over 360 degrees times 2 pi r. Remember 2 pi r, this represents the circumference. Okay, so that's one way you can think about it. You can also think about it as the central angle over 360 times pi times diameter. That's, just as the second way that we can represent circumference. Now, another way, and some students kind of prefer this second formula, is to think of finding arc length and circumference as like a part to whole relationship. And so if we take the arc measure of the central angle, which the central angle is part of the entire circle, and we have 360 degrees, which is the whole circle, we have that fraction, and that would be equal taking the arc length, which is part of the circle, divided by the circumference, which is the whole. And as we do some example problems in the next video, I'll utilize both formulas so you can decide, do you prefer using the proportion formula or do you prefer using the formula that we kind of discovered in our table above?